Welcome to Ask and Learn.
So there is a skier in this problem which is coming down a ramp. So this is a ramp. And for this problem here, this height from which the skier comes down is 45 meters. And the skier is at this location here, coming down here. We need to calculate the velocity, which is horizontal velocity at this location. So the speed VB can be found by the conservation of mechanical energy. So we'll write and describe the subscript A, represent the skier at the top of the jump, and the subscript B will represent at the bottom of the jump. So this is the point A, and this is the point B. So we know the total energy at A should be equal to total energy at B if there are no non-conservative forces acting on the system. So therefore, at this point, the total energy is half m VB squared, and the total energy is only gravitational potential, which is mgh. And m cancels, and we get the velocity as equals to square root of 2gh, which is equals to square root of 2 times 9.8 times 40.6. And the answer is 28.2 meter per second. So that is the velocity of the skier at this point, which is the horizontal velocity is 28.2 meters per second. All right, now for the B part of the problem, at this location here, there is a ramp, and the hill starts somewhere here, right at this location. So this distance they have given is 4.4 meters, and the person jumps in the air at a velocity VB, which is we have calculated as 28.2 meters per second, and he's in the air for quite some time, and then finally comes and touches the ground at this location. So we need to find out this distance S, this distance which I'm marking, which he covers on the ground at the point C. And we know that the ground is at an angle of 30 degrees. So therefore, this is also at an angle of 30 degrees here. So now we need to approach the problem. So first of all, we need to define the origin. So this position, we take the origin of the coordinates to be the point on the ground directly under the end of the ramp. So which means right at this point, we take our origin 0, 0. So if this is our origin, then the equation to describe the slope is given by y slope is equals to minus x tan 30. So we have, this is y and this is x. So that is the equation to describe the slope. And the equation of the projectile motion can be used to find the expression for the parabolic path the skier will take. So we take up to be the positive direction, and initial vertical velocity is 0, and the x velocity is given by VB. So therefore, this distance x which he travels is VB times t, because in the horizontal motion there is no acceleration. And for the vertical motion, y projectile is equals to y naught minus half gt squared, which is actually given by y naught minus half g, and t we substitute from this equation, which is equals to x, y, vb squared. Now the important point to note is that the skier lands at the intersection of two paths. The skier lands at the intersection of this path, which is the slope, and the projectile. So we need to set these two equations equal. So we'll say that the skier lands at the intersection of two paths. And the two paths are y slope should equals y projectile. So which implies that y slope is minus x tan 30, and y projectile is given by y naught minus half g times x by vb squared. So which implies that if you solve that, we will get a quadratic equation gx squared minus x to vb squared tan 30 minus 2y naught vb squared is equals to 0. So you can see that this projectile equation and the intersection of the slope equation comes to a quadratic equation with the quadratic in x here. So therefore, we can solve this quadratic. X is equals to, now we have, this is ax squared plus bx plus c. So we'll solve it, this quadratic, by minus b plus minus square root of b squared minus 4ac by 2a. So we'll plug in this equation as equals to 2 vb squared tan 30 plus minus square root of 2 vb squared tan 30 squared, this is b squared, minus 4ac, so that becomes 8g y naught and vb squared, and divided by 2g. So if you simplify that further, you will get vb squared tan 30 vb squared tan 30 plus minus, again on solving this we will get vb squared tan 30 plus 2 g y naught vb squared divided by g. I've just divided, just cancelled 2 and 2 from here and 2 from here, because you get, so this is plus. If you solve this quadratic equation and substitute the value of v and y naught as equal to 4.4, you will get the value of x is equals to negative 7.09. Two roots we'll get, and the value, another root we'll get as 100.8 meters. So we take the positive root. So finally we have s cos 30 is equals to x in the previous right angle triangle at the bottom of the ramp. So if you solve that and substitute the value of substitute the value of x as 100.8, we get the value of s as 116